Hello everyone, this video covers the lecture notes for week number 9. The main objectives is going to be to factor expressions by grouping, which we have done before at least twice. Or you need to factor a monomial first and then do grouping. The new part is going to be this, to find or to solve inequalities. And this is actually pretty straightforward. Especially you have the equation. If you don't have an equation, that's when you have, especially you have a graph. If you don't have a graph, that's when you had to go back and rely to the grouping or factoring to know where a function is positive or negative. But if you have already a graph, then it's very straightforward where this is positive and this is negative. For example, if you have a graph that looks like this, you can clearly see, let's say that this is A, B, C. So if I ask you what is this positive, clearly positive just means is above the x-axis. So this part is positive, this part is positive. It's not the same thing as increasing or decreasing. It's just straight out where this is positive or where this is negative. If I ask you where this is negative, well, that's just below the x-axis, so you can see this will be negative and this will be negative. Now the answer, you're going to write an integral notation as usual, but as you can see, this is a straightforward. If you have a graph, it's pretty easy. If they give you the equation, that's where you have to factor first and then find what is positive or what is negative. So let's start with the easiest example possible, which is this one right here. You have a straight line, and clearly you can see that at this point this is equals to 0. So the question is asking where is this positive or greater or equals to 0, including the 0. So positive, but including the 0. So you need to watch out for that part. So clearly the answer will be this. So if we write an integral notation, this is going to go from 1 bracket, because at the 1 this gives you 0, and then to infinity because it keeps going forever. Okay, assuming this keeps going forever. Now what is this negative? Remember, negative means it's below the x-axis. So this is the x, this is the y-axis. So this is below the x-axis here, and it doesn't include 0, so therefore this will go from minus infinity to 1, and this has to be parentheses because that's not part of the solution. Now what are the x-intercepts? Remember, x-intercepts, like the name says, which is the place where it's intersecting the x-axis, and the coordinates for that one is 1, 0. So you could say that x is equals to 1, that's the x-intercept, but in coordinate form it will be 1, 0. So this is in coordinates. Okay. Remember that when you use coordinates for parentheses for coordinates is very different than using parentheses for integral notation. So just keep that in mind. So this section is probably the easiest one we've done so far, because you are supposed to know already how to factor and where to check where things were increasing or decreasing. Now we're only going to focus on the positive part or negative part and the factoring when needed. Okay, so let's try a couple more examples. Right, so this one is asking for which values of x is g of x positive. Notice that it's clearly asking greater than 0, so that means 0 cannot be included in the solution. And remember, greater than 0, this just means where is this positive, okay? Or above the x-axis, okay? That's what you should be looking for. So then above the x-axis is this part. This is the part that is positive. So it is positive here and here. Therefore, the answer in integral notation is going to go from -2 to 2, and we use parentheses because remember the -2 and 2 gives you 0, and you want it strictly greater than 0. Now the next part is asking what is this negative, including 0, so it's going to be this part and this part. So therefore, this is going to be negative from -infinity to -2, including -2, or from 2 to infinity. Remember that the infinities always use parentheses. Now, what are the x-intercepts? The x-intercepts are x equals to 2, or x equals to -2, or in coordinate form, this will be 2, 0, and this one is -2, 0. Those are the x-intercepts. So as I say right now, this is a straightforward if you have a graph. If they give you an equation, things get a little more tricky because you need to factor first. But this is the key to know when things are positive or negative. Notice that this graph, it will be negative until it gets to 0, and then it's positive all the way until it gets to 0 again. So therefore, the key is to find the places where this is equals to 0, and then you're gonna do something that is called test points. So if you pick a point here and you plug it into the equation and it gives you positive, that means all of this part is positive. If you pick a number here, obviously it's gonna give you negative values. If you pick a number here, obviously it's gonna give you negative values. So you'll see what I mean right now. So if you don't have a graph, the problem is a little more tricky, but the idea is exactly the same. All right, let's try this problem. And the first thing is asking you to do is to find the x-intercepts before we find where this is increasing or decreasing. Remember that x-intercept means the f of x is equals to 0, okay? So therefore, to find x-intercepts, you said this equals to 0. That's what that means. Here, you can actually factor x cubed. So this will be x squared minus 9. So then this is x cubed, this is x minus 3, and x plus 3. So therefore the solutions, or the x-intercepts, it will be 0, 3, and -3. So now what we can tell so far from this is the following. We're gonna get into more details of this very soon. But you know that at -3, at 0, and at 3, these are x-intercepts. So that means that the graph at this point is equals to 0, and that means you only have two choices. Either the graph is doing this, or the graph is going the other way. And we're gonna find out right now. So the graph either looks like this, or looks like this, okay? So this is how we're gonna decide which one it is. We're gonna use something called test points. And all you have to do is pick numbers in between. So this one goes from 0 to 3. So you pick anything between there. Let's say we pick the number 1. Then you're gonna plug it into these three terms I already have here. If you plug in x equals to 1 in here, the first one will be positive. You only care if it is positive or negative. You don't care about the actual number. If you plug in x equals to 1 in here, 1 minus 3 will give you negative. And then you plug it into here, x equals to 1, 1 plus 3 is 4, so I will give you a positive value. And then positive times negative times positive is negative. So this is the important part, which means that the graph from here to here is going to be negative. Okay? Then pick something here like number 4 and do the same thing. This will be positive for the first one, positive for the next one, and positive for the last one. So if all are positive, that means that the graph is going to be positive in here. And it cannot come down anymore because there's no more zeros. There's only 3 zeros here. So that's very important. So do the same thing here. Let's say we pick x equals to -2. If you plug it in here, this will be negative for the first one, negative for the next one, and positive for the last one. Why? Because -2 plus 3 is 1. Then negative times positive, the whole thing is positive, which means that the graph in here is positive. And if you check, this one is going to be negative. Just like I told you, it will be one of those two. So therefore here, the question is asking, when is this negative? And all you have to do is check the part where this is negative. Clearly negative is here and negative is here. And you just have to be careful whether you have to include the parentheses or the bracket. Since this one says less than or equal, that means that you need the brackets, at least for one side. So therefore, the interval notation for the first part, this is -infinity to -3 bracket, or from 0 to 3 bracket. That's where the function is negative or equals to 0. Now, another way to determine whether it's positive or negative, if you don't want to do this, which I think this is the easiest way, you can do it in a table like this, and I think this is what you have to do for the offline homework for this week. So this is technically going to accomplish the same thing that we did here. Just, I guess, it's more organized since you do it in a table. So here first you put the points where this is equals to 0. Remember, this was 0 of -3, 0, and sorry, this will be here -3, 0, and 3. And what type of points are these? Well, this is the x-intercept. This is the x-intercept and x-intercept, and the value for f here is 0, 0, 0. So this represents these 3 points right here, and that's where you should always start. Then you can pick, let's say, the number 1, which we did here, and this is a test point, and there this one give us a negative value. And then we use the test point 4, and that gave us a positive value, which was the value here. So it's exactly the same thing that we did here, just in the table. And then we can pick between 0 and -3, we pick -2, which was another test point. And remember, at -2, this was positive. And then you can pick another test point, let's say -10 here. And clearly this will be negative. Okay. Then it's asking you to approximate a graph, which is literally the graph we have here. So we have the zeros were 0, 3, -3, and then the graph looks like this. This is actually not the precise graph, but it's very close to the real thing. And that's it. All right, you didn't get that one. Here's the chance to redeem your sins. Let's try a couple more. So we're doing the exact same thing. You need to find the x-intercepts first by factoring. And here you have 4 terms, so you have to do grouping, which we have done that before. Remember, this will give you the x-intercepts, means that f of x is equals to 0. Okay. So you factor these 2 and these 2 by grouping, and this is like the 4th time we do grouping. So here you can factor x squared, this is x plus 3. You can factor the -4, this is x plus 3. And then this is x plus 3. Remember, when you do grouping, whatever is the thing in common, which in this case is x plus 3 or the GCF, you only write it once. And whatever is left, goes in the other parenthesis. And then in this case, you can factor this one more time, the second part. So this is x minus 2, and x plus 2 equals to 0. So therefore, the x-intercepts are negative 3, 2, and minus 2. Remember, this is where it crosses the x-axis. This time, let's use the table to solve the following example. So remember the x-intercepts that we got, by the way, it doesn't have to be 3 x-intercepts all the time. Sometimes you have more. We're negative 3, 2, and negative 2. Actually, let's say minus 2 and 2. And at this point, remember, this is equals to 0. Okay. So I'm going to do the table and the graph at the same time. And actually, let me just use the graph from here. So we already know that this is 0 here, here, and here. And again, the graph is either going to look like this or like this. Those are the only choices you have. And this time it's asking you where this is positive. So once we complete the graph, that's what we have to focus on. All right, so let's start with the easiest one. Let's say we pick x equals to 0, which is in here, which is between these two. So the test point will be 0. So what is the answer you get, positive or negative? So if we look to this part, if x equals to 0, the first part is positive, which is this one. The second one is negative, which is this part. And the last part is positive. So again, if you multiply all of this will give you a big negative sign. So that means that between here and here, this is negative, or that this is negative. Then pick another value. Let's say the number 3. So x is 3. So these are the test points. So let's say we say test point x equals to 3. Do the same thing. 3 plus 3 is 6, which is positive for the first one, positive for the next one, and positive for the last one. And again, you multiply 3 positives, you end up with a positive number. So that means this part is also going to be positive. Okay, so this will be positive. Now you need to still pick one in here and one in here. So let's say we pick for between those two, we pick minus 2.5. So we pick x equals to minus 2.5. The first one will be positive. This is positive, this will be negative, and this will be negative. And when you multiply everything, this will give you positive again, which is not surprising that this is going to be positive, so therefore this will be negative. So this is positive. And then let's say that the last test point we pick is like minus 4. We already know it's going to be negative. Now this question is asking you what is this positive, including the 0. And positive is this part, this part, and this part. So therefore the solution in interval notation is going to be from minus 3 to minus 2, or 2 to infinity. Now in this case, if we want to make the graph more realistic, which is not asking you to do that, but if you wanted to do it more realistic, the y-intercept is actually the y-intercept for this then is minus 12, because see, this is 0, 0, 0. The only thing left is minus 12. It's not asking you for that, but if you want to make it more realistic, then the graph will look like this. All right, well, you didn't get the last two. This is your last chance to redeem your sins. So here it is. So literally we're going to do the exact same thing, except that this time is asking you where this is positive, not including 0. So remember, the first thing we do is you need to factor this to find the x-intercepts. And to factor, we need to do grouping. So group these two and these two. So here we factor x squared, this will be x minus 2. Here you factor the 4, this is x minus 2. Remember that every time you do grouping, these two have to be the same. Once you get the same thing, you write it once, and whatever is left, which in this case is this, it goes in the other parentheses. And usually you can factor this one more time. So this will be x minus 2 times x plus 2 equals to 0. Notice that this time you actually only have two x-intercepts. X equals to 2, because these two gives you the same, and x equals to minus 2. So therefore, if we do the graph, you only have two zeros now. One of -2 and the other one at 2. So you only have to check points here, here, and here. So the easiest one to pick in here, it will be 0. So we're going to pick here x equals to 0. Here, let's say we use 3 and -3. So this will be the test point. It will be a test point. It will be a test point. Now, this one is a special case because you have a repeated solution, and we will go into more detail about repeated solutions in the coming weeks. For now, let's just do exactly the same thing we did in the previous two examples. So we're gonna need to test here, here, and here. So we're gonna use the values -3 for the test point, the value for 0 for the test point in here, and 3. You can pick anything you want between the intervals, but this is as easy as it gets. So now if we use, let's start with x equals to 0. Then the points where this is equals to 0, remember, is -2 and 2. And we pick x equals to 0. The first one will be negative. Then by first one I mean this will be negative, this will be negative, and the last one is positive. So the whole thing is positive. So therefore from here to here the graph is positive. So now let's say we pick now x equals to 3. So the first one will be positive, positive, everything is positive, so the whole thing will be positive. So that means that this is why this is a special case. It hits 0 and then automatically goes up. Now if we use -3, this will be negative, negative, negative. So the whole thing will be negative. So once it gets to once it passes -2, the graph will go down. Okay. So now the question is asking for part A, where is this positive? Well, positive, not including 0, is this part, and also this part. Okay. So here you have to be careful how you write it because it's not asking for greater or equals to 0. So positive p of x positive, it will happen between -2 and 2, not including the 2 because at that point it's 0, or 2 to infinity. Okay. Note, if the question was the interval where this is greater or equals to 0, or you could just say from -2 to infinity, and that will be it. And then part B is asking to do a graph, which here is the graph is supposed to look like this. Now you should finish the table. Again, you can either do the table or do this. You don't have to do both. But here the x-intercepts, remember we only have 2, it was -2 and 2. And then for the test points we use 0, -3, and 3. and this one gives you positive. This one was 0, this gives you positive, this is 0, and this gives you negative. And that's it for week number 9.